Today we're going to talk about vertex form of a quadratic function in comparison to a standard form. We're also going to discuss how to graph a quadratic function using either standard or vertex form. So a couple things to discuss. So the first thing that we need to talk about is what is vertex form. So it's written in the form y is equal to a multiplied by the difference of x and h squared plus k, where a, h, and k are just numeric values that represent different parts of that form. So the vertex is represented by h comma k. So the actual ordered pair comes straight from the vertex form, where h is here and k is here. The axis of symmetry is, of course, just that x value, so x is equal to h. Whatever your h value is where we're going to draw that vertical line. The only thing that's a little bit tricky on these is to be careful with your positive and negative signs, because if you look here, the actual form with standard form, everything was a positive, so if we saw a minus sign, we knew that that number or that value was negative. In this case, we have a minus sign as a part of the actual vertex form, so if you see the opposite of that, you're going to need an opposite sign. So if it's a minus h, whatever this value is, that's a positive value, but if you see a plus h, then it's going to be a negative value when you pull it out. So just be aware of that. K stays as it is. If it's a positive k, then it's a positive number, and if it's a minus sign there, then it's going to be a negative. So just that h value can get a little bit tricky if you're not careful. So a couple of just quick reminders. If a is positive, then the parabola opens up, and if a is negative, then of course it opens down, meaning it's going to be moving, opening up at the top of the graph, whereas down here it's opening down at the bottom of the graph. So let's look at this first example, x plus 2 squared minus 10. So on this one, a is the number that's outside of those parentheses, and in this case, there isn't a number there, so we understand it to be 1. H, this is what we were discussing before, is there's a positive 2 here. And so normally, the vertex form itself has a minus h here, so because it has an opposite sign, we're going to actually pull that out as a negative 2. And then here we have a minus 10, and with that minus 10, the k is originally positive. Since it's an opposite sign, we're going to pull it out as a negative 10. Okay, so with that information, the axis of symmetry is just the h value. At negative 2, x equals negative 2, so that's this point right here, vertical line right here, that is our axis of symmetry. And you can see that my parabola is split down the middle, symmetric on both sides of that line. That's what the axis of symmetry is. And then if we use this vertex representing hk, well, h is negative 2 and k is negative 10. If we plot that point, we see that that is the vertex, or the minimum point, the turning point of our parabola. So same thing over here with a negative example. Here there's a negative sign outside the parentheses, so we understand that that is a negative 1 for the a value. H is a minus 1 here, so since it's the same sign, we pull that out as a positive 1. And then the 5 also has a positive or a plus sign, which is the same as the original vertex form, so we pull that out as a 5 as well. So the axis of symmetry here is going to be h is 1, so if we go to 1 and we draw our vertical line, we have a line at x equals 1. That's our symmetry. You notice that it's symmetric on both sides of that line. Okay, then we have the vertex point, which is going to be the 1, 5, and we would plot that point, and you see that, yes, of course, it is our turning point, our maximum point for this parabola. Okay, so to talk about graphing quadratic functions using either vertex or standard form, what we need to understand is that it doesn't really matter which form it's in. We can graph it either way. One of the ways, or the steps that we're going to follow for this, the first step is to find the axis of symmetry, either using the formula or the vertex form of the equation. Doesn't matter which one. If you're using the formula from one of the previous methods that we learned, or if you just are looking at that vertex form and you can pull out that axis of symmetry. Either way, you need to find that. You also need to find the vertex, whether you're using that axis of symmetry and plugging it into the standard form, or you're taking the vertex and just finding it straight from that form. Either way, you need that vertex. Once you have the vertex, you're going to create an XY table that has at least 5 points. That's bare minimum that you need to create a good looking parabola. You're going to put the vertex in the middle row, and then they're going to fill in the table of values, either by hand or with the help of your calculator. So if you do it by hand, that means you're going to be plugging in each x value and finding the y value, plug it into the equation. And if you want to use your calculator, I can show you how to do that as well. I'll do that here in just a minute. The final thing you're going to do is plot those points, those 5 points, and connect them with a smooth curve. Remember that a parabola does not have a point. It has a smooth curve. It's a U shape, not a V shape, okay? So let's take just a minute, and I want to do one example with you from the back, and we're actually going to pick from the middle. We've done several examples with finding axis of symmetry and vertex from the standard form, so we're actually going to do an example with vertex form. So we're going to look at example number 3 on the back of your notes, and we're going to discuss that together. So if you look at number 3 here, the first thing we need to do with the vertex form is we need to know what our values are. So A is 1 in this case. There is no value there in front of the parentheses, so it's understood to be 1. Our H value is going to be a positive 2, and our K value is going to be a positive 3. So according to our vertex form and what we know about it, our axis of symmetry is the same as the H value. So X is 2. So our axis of symmetry on our graph is going to be at positive 2. So there's going to be a vertical line here that splits mine in half. So maybe a good idea to draw that axis of symmetry on there so that you know where to find your values. From there, we know that HK is our vertex. So 2, 3 is our vertex point. So 1, 2, 1, 2, 1, 2, 3 is going to be our point, 2, 3. So that's going to be our point. Now, our A value is positive, so this is going to be opening up. So if I start noticing that my points are going in the wrong direction, I know that I may want to go back and double check what I'm doing, okay? So here I have an XY table. I'm going to put my vertex here in the middle, and I'm going to go 2 numbers below that, so 1 and 0, and I'm going to go 2 numbers above that, so 3 and 4. So there's a couple of ways to do this. So the first thing we could do is we can go through each of these x values, plug them into the equation, solve, and write down the y value. So for example, I could do y is equal to, and in place of the x, I could replace the 0, and I can simplify. So 0 minus 2 is negative 2 squared plus 3. That's 4. So y is equal to 7 in that case. I can do that for every one of these. And there's nothing wrong with that because sometimes we don't have a calculator available or whatever the case may be. The other option that you can do is you can go into your calculator, okay, and we would start off, it's on, we go to y equals, this button here at the top, we type in this equation just like this. So y is equal to, in parentheses, x minus 2, close the parentheses, squared, plus 3, okay, and then we go to second graph, which is the table button. And if we look, here are our table of values. So at 0, 7, okay, we got that one right. We can scroll down. We have 1, and the y value that goes with that is 4, 2, 3, 3, 4, and 4, 7. Okay, and so that's 5 points that I can plot on my graph. So I already have my 2, 3. I also need to plot 1, 4, and 0, 7. And then I need to plot 3, 4, and 4, 7. And then I'm just going to connect that with a nice smooth curve. And there is my parabola drawn. So you're going to continue this process practicing with the additional practice problems that we have here.